Hello guys, welcome back to my channel Code Cruxes. Today we will solve another problem of the series of most important questions for companies, and today we will solve another problem from the Google series. Okay, so the problem name is maximum index. We are given an array of n positive integers and our task is to find the maximum of j minus I subjected to the constraint such that ai is less than or equal to aj and I is less than or equal to j. I hope the problem is clear. Suppose, let me take an example. Our array is 9, 10, 7 and 8 and the index will be 0. Yes, I shifted to Google Docs because it provides me better coding and errors will not display here. Okay, so this is our array and this is our index, right? This is my array and this is my index. Okay, so what we have to return here, we need to return element such that a of j, like in this case 10 is greater than 9, 8 is also greater than 7, but the difference is same. J in first case is 1 minus 0, that is 0, right? So, 1, right? And hence this will be the answer. The answer equal to 1. The answer will be the maximum difference of j minus I such that aj is greater than or equal to ai, right? So let's think about a solution. First of all, I will tell you the first strategy today. The naive solution is simply by running nested loops, right? First of all, if you get nothing, then just try to start with the naive solution. Just approach 1 is naive solution. Just tell them the naive solution. It's alright. And then move on thinking better versions of it. Second approach, we will think of something like sorting. Whenever there is a thing about greater than and equal to, sorting comes in our mind and it is completely fine. But here the problem is we need to keep in mind the tracks of the index also. So what I will do, I will take a pair or I'll take a vector. Suppose here I have taken vector of pair, right? So I will take a vector of pair which will be both int and it will contain both my things. It will contain, the first thing will contain my array elements and the second will contain my index. Okay, so in this way we can like do this. Okay, so what will happen? I will then sort the array based on my first array elements, that is based on the array elements. So my array pair will look like something like 7, 2, then 8, 3, then 9, 0 and then 10 and 1, right? My array will look like this. And hence, now we have got this array, we need to think of how we can reach to the answer. If you notice carefully, then our array is sorted and hence in this case our ai will always be less than or equal to aj, right? This condition is fulfilled. So now we just need to check how we can make the j greater than equal to I. And for it, what I will do, I will firstly initialize my j with some minimum number, that is I will initialize with a0 dot second. Like my j initially will be 2, right? The first element. After that, what I will do, I will also take an answer res which will be equal to 0 initially, because maybe the answer is not at all present, maybe all the elements are, suppose maybe all the elements are 1 1 1 1, then answer is not present and hence our res will contain that answer which is 0. Okay, and after that what I will do, I will run the loop. I will run the loop from int I equal to 1 and like this, right? And then I will check if my array, or not array, actually this is answer, because answer is containing the two pair, right? So it's answer. If my answer I dot second is greater than or equal to mn, like we have found something like this, this means that our array was this, right? 7 2 8 10 and this. Let me copy it and paste just above it. Yeah, this is our array and hence what we need to check here, if my array I dot second, this answer I dot second is greater than 2, yes it is, then what I'll do, I'll update the answer. That means we have found an index where aj is greater than or equal to ai already, and j is also now greater than I, and hence I will update my answer as the max of rest. Maybe the answer is already like greater than this, and I will update it as answer I dot second the index minus mn, like this is our, and also we will take mn as the minimum of mn and answer I dot second. Why are we doing this? This is because maybe it is possible that here we have a number 5, but now this is smaller than it, and we want the greatest difference of them, right? We want the greatest difference between them, and hence 5 minus 3 will be like what I am doing here, I am taking the minimum of them, because after it we are finding the maximum, right? So 5 minus 3 will yield me 2, but there is a possibility that I find a smaller element, and suppose not 13, 13 is there, my greatest element is 13, and hence if there is a possibility that I find j as 2 somewhere, then 2 minus 13 will be greater, this difference will be greater than 5 minus 13, and hence we are doing this change. So I hope you got the crux of this. The crux of this is simply sorting the array and like declaring it like this, and then writing this code, like checking these conditions. If answer I dot second becomes greater than equal to mn, that means we have found one answer, and hence we will update our rest, and also then we will take the minimum value so that we can maximize our answer. So I hope that the code first is clear. It will take off login time because our sorting algorithm is login, or I think it is n login if I'm not wrong. Let us check. Sorting, I sometimes miss this part. We can also check it, but let's just Google it for time being. Time complexity. What is the complexity of sorting algorithm? Yeah, the worst case time complexity is of, they have not written it correctly. Searching and sorting algorithm. I hope that we find our answer somewhere. Yeah, so here we have all the, let me search it in better way. STL C++. I think now we will get our solution. Sort function in C++, exactly. I want this. I want the time complexity. Yeah, it is O of n log n. So yes, sorry guys, it's the n log n solution, but it's still better than n square, right? So this is our first solution, which you can tell in your interviews, and we will further like update it to code 2, that would be our O of n solution next time. So just to let you go through the code, this is the code that I have written. It is exactly the same that I have tried to explain. First of all, we took a vector of pair of answer, and then I pushed all the elements of our array and their index in my answer, and then I sorted it. This is of the complexity of n log n. Let's try to remember it. And then I have declared two variables mn that will contain our minimum index and answer, that is the rest. And here I am checking the same condition. If I found an element answer I dot second here represent, answer I dot second is nothing but our j which we are trying to find, and mn represent nothing but I. And when we get this that j is becomes greater than I, then we just simply update our answer that yes, we have found one answer, and we will take the answer that is maximum, and then we also initialize our mn with a minimum value to maximize our answer, right? Maximize our answer. And hence this is the code. Lastly, we return this. So let's try to submit it. Test case processed. Yeah, it's working fine. Obviously, it will take much time than the solution we will write, which will be the most efficient. But now for time being, this is my first solution. I hope you got it. You got the crux. The crux is these things, and also thinking about the sorting algo whenever these types of constraints come. Mostly they can be solved by sorting algo. So that's it for today's video, guys. Hopes we'll meet you next time. Bye.